Welcome, ladies and gentlemen, and we are back at Math Online. So we're looking at quadratic application problems next, and these are very exciting. So we're looking at the profit made by an ice cream company is shown by the graph below, where y is going to be the profit in dollars and x is going to be the price of a pint of ice cream. So to keep ourselves understanding what's going on, we'll do profit. Woohoo! And we will do price per pint. Okay, so what is the maximum profit that can be earned by the ice cream company? So it's a profit versus price. You do understand that that means that the vertex in terms of x comma y will be given as price versus profit. So in other words, it's the y value that will give us our maximum profit. So when I see the vertex here, and I see that that vertex is going to be at approximately 3.5 comma $160,000, what I'm noticing is that my maximum profit is found by that vertex, and it's going to be $160,000. Not bad for making ice cream. All right. At what price will they need to sell their ice cream to make this profit? Well, again, using what we know about this vertex, that maximum y value is going to occur at 3.5, which in this case represents $3.5 per pint. That's called interpolation. That's when you find information within the data points that you're given. That's a callback to grade 9 math. Okay, what is the lowest possible price that they should charge for a pint of ice cream? Well, the lowest possible price that they should charge for a pint of ice cream is probably $3.50, so they make the maximum profit. But that's not what we're going for here. We're looking for what's the lowest price that we can sell our ice cream for and not lose money, because that's a bad idea in the ice cream business. So if we wanted to get our name out there and give away as much ice cream as possible and not lose money, then we should make sure that we are selling it for $1.50 per pint. That means that we will not make any money, people. It's a sad day in the ice cream business, but we won't lose any money. What happens if they charge less than that amount? They go out of business. Can we say receivership? So they lose, I can't spell lose, L-O-S-E, lose money. Bad idea. We'll even do a sad face for that. Okay, so what is the highest possible price that they could charge? Well, again, I would argue they should charge the price that gives them the maximum profit. But hey, what they're really after here is what's the highest price they should pay without losing money again. And they can, if they want to be, they can be the most expensive ice cream out there. They can charge $5.50 per pint and not lose money. Not making any money, but hey, they're expensive. That might be the goal. So, which of the following equations could be correct for this graph? Now, that's an interesting logical problem. I'm not saying which one's right. I'm not asking you to find which one's right. I'm asking you to tell me which one could be right. In other words, I'm asking you to find me which two. That's a different way of thinking about things. So, let's look at this one. Could this be right? Well, this seems to have a positive a value. If it has a positive a value, then it opens up. So this has a positive a value. That means that the parabola opens up. Does this parabola open up? No. So this one is not correct. Wrong. So that one's out of the picture. Which one else is out of the picture? This one has a negative a value, so it opens down. This one has a negative a value, so it opens down. Okay, cool. Ooh, look. It has a positive here. That means it's going to have a vertex of negative 3.5, 16,000. That means to make maximum profit, they should give everyone $3.50 for taking a pint of ice cream? That's silly. So this is in the wrong quadrant. So this means giving money to people to take the ice cream. That just doesn't make sense to anyone. So this would be not correct. That leaves the only one that could possibly be correct is this one because it opens down. And this one, it has a vertex in the right quadrant. So I don't have a reason why this is wrong. So this is most probably, well, of the three, this is the one that could be correct. Yay! Okay, I'm going to flip over now, and we're going to do question number 2. All right, Luis. Luis is going to kick a soccer ball. Good old Luis. And the ball is going to follow this equation, where y is the height of the ball above the ground, and x is the distance away from Luis in meters. So this is distance from Luis. And this is height above the ground. Okay, so state the transformations. Woohoo! This is yesterday's work. How many transformations do you see here? I see 4. How many do you see? Count. I see a reflection. I see a vertical compression. I see a horizontal shift. And I see a vertical shift. I see 4 transformations. You better too. So, in order, the red ones have to come before the green ones. I don't care which of the red ones come first, and I don't care which of the green ones come first, but the red ones before the green ones, otherwise you lose marks. So, there's a reflection in the x-axis. Number 2, vertical compression by 2, or you can say multiple of 1/2. And I made a big deal about that yesterday, and you should understand the difference. Then you have a horizontal shift to the right or to the left, to the right or to the left, come on, come on, to the right, 4 units. And then you have a vertical shift up 8 units. And those 2 must come before these 2, otherwise you will not get full marks and you will be sad. Okay, step pattern. Step pattern is over x down, because of the negative, 1/2 x squared. And we've been doing that so much, you better know it by now. So let's graph this puppy. Graph the equation. Okay, I'm going to start by putting in the vertex. The vertex up here is going to be 4, 8. So 4, 5, 6, 7, 8. Who do we appreciate? Mr. White. No, just kidding. Okay, 4, 8. That's our vertex. Okay, so what's next? Let's do our step function. Over 1, down 1/2. Over 2, down 2. Over 3, down 4.5. If you don't remember how to do this, please review what we've done in the last few days. And over 1, 2, 3, 4 from the vertex, I should be going down 4 squared, which is 16. I should go down 8. Oh, looky, looky. They're my x-intercepts. And if I go over 5, I should go down 25. And half of 25, I think, is 12.5. Is that right? So if I go over 1, 2, 3, 4, 5, I should go down 25. Half of 25 is 12.5. So that's down 8, 9, 10, 11, 12.5. And I have a beautiful looking set of points there. Now, are those all the points? No. So we're going to draw the nice curve. Look at how it's a curve, people. Look how it is curvy. There's some of you out there that don't have curvy parabolas. You know who you are. Do not become a non-curvy parabola person. Okay? So, curvy parabola. On the graph, show where the ground's located. Come on. This is the ground. Because this is the height above the ground. Therefore, that's the height below the ground. On the graph, show where Louise is standing. That's where Louise is standing. She's standing right there. Highlight the part of the graph that represents the actual path of the ball. So Louise kicks the ball. Boing! It goes up into the air. Boing! And then it comes down and it hits the ground. Now, does anyone believe that it goes below the ground? That someone went over there, dug a hole, and the ball goes through it? No. So the ball hits here and then probably bounces off, but it's not following this graph. So this is the path of the ball. In words, explain why you did not highlight the other parts of the graph. Well, after 8 meters, the ball would bounce back into the air, not fall below the ground. Well, unless there was a hole or a cliff or something that I don't know about. And before 0 meters, Luis has not kicked the ball yet. And also, it would be below the ground coming to Luis, which makes no sense at all. So that's just nuts. How high is the ball at the highest point? Well, 8 meters. But do I really need this curve to see that? The answer is absolutely no. I could see it from the equation. It's right here in the vertex. How far away does the ball land from Luis? 8 meters. But again, did I need the graph to say that? No, I know my vertex is 4 meters. So half the distance will take me to my highest point, and another half that distance will bring it back down to where it started. So as long as it's not interfered by anything, then it won't matter. So now it's break time for these kids, so I'm saying goodbye to them. They can sign out and go if they need to, and you and I will finish this question. Joseph. Joseph is 1.5 meters tall. He's standing 3 meters away from Luis. Show where he's located. 1, 2, 3. Here's Luis. And he's 1.5. Not Luis. Who is this? Joseph. 1.5 meters above the ground. There he is. Let's just call him Joe for short. That's what all his friends call him. All right. So if Joe stands there, is he going to be able to touch this ball if he doesn't do anything? Nope. It's going way over his head. So if Joseph does not move, will the ball hit him? Nope. Why not? It flies with the greatest of ease. It flies over his head at 3 meters away from Louise. And I'm going to stop there, and we'll do the last little bit in just a moment.